Good morning and once again welcome to my YouTube channel, Pearson Edexcel International Mathematics by Mr. Kamoto, and today we are explaining quotient rule. Quotient rule is found in chapter number 6 of Pure Mathematics 3 and on page 194. And I want us to just understand quotient rule before we can learn how to use it. And you need to be able to differentiate the quotient of two functions. And we start by saying if y is equals to u over v, you can say that is a quotient. Then dy dx is realized by v du dx minus u dv dx all over v squared. And I will explain this. uv dy dx is given by the denominator v multiplied by the derivative of the numerator du dx minus the numerator u multiplied by the derivative of the denominator v dv dx, and everything over the square of the denominator. And that is just what we generally know as the quotient rule. And if, for example, the quotient rule, the function, it's in form of functions of x. The quotient rule in function notation now, we are told that if fx is given by the function of x at the numerator gx over the function of x at the denominator hx, then the f prime x, which is the derivative of x, derivative of the function, is given by the denominator, which is the function of x hx, multiplied by the derivative of the numerator g prime x minus the numerator gx multiplied by the derivative of the denominator, which is h prime x, everything over the denominator squared, or hx squared. This is now the quotient rule in function notation. And I just want us to explain in the same video something to do with just example 12 on the same page down there. Given that y is equals to x all over 2x plus 5, this one is already in the form of u over v. So find dy dx. Before we can go finding dy dx, let us first of all outline what is our u. Our u is x. What is u prime, or the derivative of u, which is 1? What is our v? Our v is 2x plus 5. And what is our v prime? Is just 2. You can see that. Meaning that if we want now to get the dy dx, we are going to have the denominator, which is v 2x plus 5, 2x plus 5, multiplied by the derivative of u, which is 1, minus the numerator, which is x, multiplied by the derivative of the denominator v, multiplied by the derivative of the denominator dv, which is 2, x multiplied by 2, we may have that, everything over v squared, the denominator squared, which is 2x plus 5 squared. And what does this give us? Dy dx entirely becomes 2x plus 5 minus 2x. Just open that bracket, all over 2x plus 5 squared. Clean up the numerator a little bit and you have 5 all over 2x plus 5 squared. And that is the derivative of this function, the function x over 2x plus 5 using the quotient rule. If you didn't understand the use of the quotient rule, it would have been too much work because you'd have taken the denominator at the numerator, and of course when it is going to the numerator, it's going to be raised to power -1, and by then you're going to use the chain rule, and after which you will employ the product rule. The chain rule will be negative. We will employ the chain rule because it will have a power, and of course since it's going to be multiplied by x, then you will eventually use the product rule, which is a bit too much of work when you have the quotient rule. Again, my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. Subscribe and share widely, and let us work together. All right?